Hello, this is Professor Eckhouse, and today I am talking about section 1.3, which is about rates of change and the behavior of graphs. So the learning outcomes are to find the average rate of change of a function, and this leads us directly to what we do in calculus. So I know this is introductory to precalculus, but it's actually really important for calculus. We're going to use a graph to determine where a function is increasing, decreasing, or constant. Again, very important for calculus. And to use a graph to locate the local and absolute maxima and minima. All right, so the average rate of change. There are 4 different ways to think about this. So the first way is to think that it's basically just the change in output. If you're going to have output and input as the way you think about a function, over or divided by the change in the input value, how much it changed. All right, another way to think about this is probably something you've already seen before, and that is change in y. So remember that this little symbol right here means change in, or just change, okay? Change in, over delta x, change in x. So that's, remember the way we say that is delta. Delta delta is the Greek basically for change. It's the letter D basically in the Greek alphabet, but we use it for change in math and in science. All right, so another way to think about that, you've probably seen this as well when you're talking about slope, because this is slope. This is what we're talking about is slope when we talk about a rate of change, is y2 minus y1 over x2 minus x1. Another way to look at that, because we've talked about the fact that f of x is just y, right? So that means f of x2 minus f of x1, the value when you plug in x2 minus the value when you plug in x1, over x2 minus x1. So stop for a moment and think about all of those and make sure that they all make sense to you. So the first kind of problem we're going to look at is how to compute the average rate of change from a table. So the first thing you always should do when you get a table or a graph is just forget about the question, really. You can skim it real quick, but really look at it and see what's going on so that you understand the table. Don't try to use the table if you don't understand it. So it says, using the data in the table below, find the average rate of change of the price of gasoline between these 2 years. So let's take a look at what we've got here. So before, they had y and c of y, and y was actually x, which is really confusing. So y stood for year, but I just changed it to t for time, okay? So the t is time, and c of t is the cost, price of gasoline, based on time, dependent upon time. So I wrote it as c of t. Between 2007 and 2009. So the first thing I'm going to do, and you can do this with a highlighter, you can do it with a bright colored pen or just your pencil, is go and find those 2 years, because that's what we're working with here, okay? So that's where you should start. So the average rate of change is going to be change in y over change in x. That's the one I use the most because it's just easy and fast to write. So we've got the cost in 2009 minus the cost in 2007 over the change in x, which is time, 2009 minus 2007. All right, well, the cost in 2009 is here, 2.41, and the cost in 2007 is here. Got a little delay in my internet here, 2.84. All right, so that means we're just going to write $2.41, and you can put the dollar sign if you want to keep track of that, minus 284 over 2 years. Over 2 years. Okay, notice we're going to get a negative. So don't be shy about getting negatives. It's okay. You just need to keep track of which one is the first and which one's the second, and do them in the same order, which I believe that this notation right here really helps with. It really helps to keep track. All right, so now we're just going to do the subtraction, and we get 0.22, and it's negative, so it's negative 22 cents. Sorry, that is not right. I jumped ahead in my notes. That is not correct. Let me redo that. We get negative 0.43, and you could put dollars, or the dollars right here, whichever one you want. I think it's more accurate to put it after the minus sign, over 2 years. Okay, so what that comes down to is you get negative 22 cents per year. Okay, so that means 22 cents per year. I can write it that way, 22 cents per year, if you want. Okay, so the next skill you need to have under your belt is computing the average rate of change from a graph. So here it's asking us to find the average rate of change on the interval -1 to 2. So let's think for a moment about what this -1 to 2 means. So that means going from -1 and including -1, that's what the square bracket means, up to 2 and including 2. So I'm going to mark that on my graph here, -1 to 2. Okay, so those points are going to be at -1, you come up to the graph and you find the point on the graph. And at 2, you could do the same thing and find the point. So now I'm going to go ahead and say what those points are so I don't get anything confused. And I'm going to call this one 2, 1. And I'm going to call this one -1, 4. So those are the points. All right, so remember, what I've circled up here in pink, this is not a point. That's an interval, and it says so right here. It says interval. Okay, it's not a point. So you've got to keep the bracket type straight depending on the definition that it gives us in the problem. So be careful. All right, so we've got these 2 points. I'm going to call this one 1 and this one 2 so that I can keep it straight. Okay, all right, so let's go and find the average rate of change. So we're going to have delta y over delta x. So that means y2 minus y1 over x2 minus x1. And the reason I write this is I cannot tell you how many times students mix the 2 up and then they get the wrong sign on their answer. So just be careful and check yourself at the end. So y2 is going to be 1. y1 is 4. Okay, so 0.1 and 0.2 I've labeled up there. x2 is 2. x1 is -1. And I put it in parentheses because I'm going to have minus a -1. So I get 1 minus 4 is -3, and 2 minus -1 is 3, and so I get a slope of -1, or my rate of change of -1. Remember, that is just the slope, and we're going to be getting to that in another chapter just as a review, but hopefully you remember that that is the slope. So the rate of change is going from the point at the top down to the point at the bottom. So the slope is negative. So make sure that what you get makes sense. Okay, in this next example, we are looking at how to find the rate of change algebraically. So this is our third way. First it was from a table, then it was from a graph, and now it's algebraically. Okay, so no picture, no table. We just have the equation. All right, so the first thing we need to do is name these two things. So we're going to call this one x1 and this one x2. So remember, this is an interval. This is not a point. So that means that we're going from one x to another x on the x-axis. Okay, so we're going to have y1 is going to be f of x1. And y2 is going to be f of x2. So it's a good idea to just kind of start there. So f of x1 is going to be f of 2, and f of x2 is going to be f of 4. So remember, this is x1 from up above and from right up here. And x2 is here, it's 4. All right, so now we just have to plug it in. So we've got x squared minus 1 over x. So for the first one, we get x squared. So x is 2. So we get 2 squared minus 1 over 2. So we get 4 minus 1/2. And that is going to give us, if you want to do it, the fractions, 8/2 minus 1/2 is just 7/2. And I'm going to leave it as an improper fraction. We usually use improper fractions. All right, f of 4 is going to be 4 squared. And I usually use parentheses because sometimes I have negatives and it keeps me from making mistakes. 1 over, and I should have put 1 there if I'm going to be consistent. Okay. So now I've got 4 squared is 16 minus 1/4. So 16 is 64 fourths. Minus 1/4 is 63 fourths. All right, so now the rate of change is just going to be y2 minus y1 over x2 minus x1. So now y2 was 63 fourths, y1 was 7/2. If any of this ever confuses you, pause the video and just think about it. Okay, stop it. That's the joy of having a video. Just stop it and think about it. x2 is 4 and x1 was 2. All right, so now we just have to work this out, and I get 63, and I'm not going to give you a lesson on fractions. If you need a lesson on fractions, you should probably go back to the algebra review. 14 fourths over 4 minus 2, which is just, I'm just going to go ahead and change that right now to be 2, just to keep things simple. So I get 49 fourths over 2, which is 49 eighths. Okay, so that is the average rate of change. Okay, so this next problem is an applied problem to physics, and it's about the electrostatic force, which is measured in newtons between two charged particles, can be related to the distance between the particles. So the force, the electrostatic force, which depends on d, which is, so how you write that is right here. So that's y. That's the dependent variable, equals 2 over d squared. Okay, so that means that d1 is 2. This is d1, and this is d2. Okay, so we just need to find the average rate of change, just like we've been doing, but just to an applied problem. So y1 is just f of d1. Okay, and d1 we just said was 2, so f of 2. And f of 2 means we're going to take 2 over d squared, and d is now 2 squared, equals 2 over 4, which is 1/2. Again, if you need to pause the video at any time, just pause it and think. All right, so we've got y2 is going to be f of d2, the function related, or the force related to d2. And that is going to be f of 6, which is 2 over 6 squared, which is 2 over 36, which is 1 over 18. All right, so more fractions, but the rate of change is going to be y2 minus y1 over x2, or which is d2 minus d1. Those are the x's. All right, so we get 1 over 18 minus 1/2 over 6 minus 2. All right, so 1/18 minus 9/18 is the easiest way to do that, and 6 minus 2 is 4. All right, when we take 1 minus 9, we get negative 8 over 18 over 4. All right, which is negative 4 over 9 over 4. The 4s are going to end up canceling, and you get, or dividing out, you get negative 1/9. And the unit is newtons per centimeter. Newtons per centimeter. Okay, so that's our answer there. Okay, so I just wanted to take a moment to show you what that looks like on a graph and what the average rate of change is, what we just found. So the distance is what we want to know what the distance is, how it the rate of change between a distance of 2 centimeters and 6 centimeters. So the rate of change is this line right here. In other words, it's the slope of this line. So this black line is the graph of the equation, and you'll notice it goes over here too, but that doesn't make sense because you can't have negative distances in this way between two particles. So we only look at the positive side. The nice thing about this curve is if we looked at what is the rate of change between 1 and 6, and we would find it to be a lot steeper. Okay, so the rate of change is a lot greater. Okay, so this last example that I have in this section is finding an average rate of change as an expression. This is something that's really important to be able to do. You'll see it again at the beginning of your Calculus 1 class or Applied Calculus. You'll see them in both classes. So this is something that's important to know how to do. So if it's confusing for you, you might want to stop, pause, go back, make sure you understand. All right, so rate of change is just going to be, so remember, this is our x1 and this is our x2. Okay, so if we plug in x1 and x2 into this expression, we're going to get what we're looking for. So we're going to look for g of a minus g of 0, and I'm using g because that's what the function used right there, over a minus 0. Okay, so g of a, it's going to be a long one, but we just have to plug in a every time we see a t. So every single time we see a t, we just replace it with an a. Pretty straightforward. So we get a squared plus 3a plus 1. Okay, and I'm going to put it in parentheses because it just makes it more clear that that was g of a. Okay, now we have g of 0. So now, and it's subtracted, so be careful. You're going to subtract, you're going to put 0 in every single time you see a t. So 0 squared plus 3 times 0 plus 1. So the only thing that's going to be left there is the 1. Everything else is going to go away. All right, over a minus 0 is just a. All right, so now we just have algebra to do. So we've got a squared, don't know where that came from, a squared plus 3a plus 1. The 0 squared is going to go away because it's 0. And the 3 times 0 is going to go away. So I'm going to cross those out so that they're kind of out of my line of sight and I don't have to think about them. So now be careful because I've got a minus a plus 1. Minus plus 1. So that becomes minus 1. All right, that's all over a. All right, so now we get a squared plus 3a, and what happened to the 1 minus 1? Those are going to go away because they subtract out, and then we get this over a. Now, so what I noticed right away is I've got an a in every single term. So remember, in order to divide anything out of a rational expression, a fraction with algebra in it is a rational expression, you want to divide out factors. You can't just go dividing it out of terms any which way you want. So you've got to factor it out first. So we've got to factor out the a, and we get a plus 3 over a. So now remember, this is multiplied times that. A times a plus 3. So now we can divide out or cancel out this a, and we're left with a plus 3. So the final answer here is just a plus 3. So that is the rate of change when you go from 0 to a on the x-axis. In this equation, your rate of change is going to always be a plus 3. What that means is, what if I am going from 0 to 7, for instance? So I'm just going to I'm going to do this in a different color. Say my interval is 0 to 7. Now, of course, this only works if you start at 0. Okay, you've got to start at 0. It can't be anywhere else. But if I go from 0 to 7, that means that then my rate of change is then equal to a. This was a right here. 7 plus 3, which is 10. So my slope is 10. My rate of change would be 10 if my interval was 0 to 7. So that's how this helps us to use this as kind of a general equation. All right, I'm going to stop here. I'm only a little less than halfway through today's lecture, but I'm going to stop so that you can take a break, and then you can go back and do the other half of it, which is kind of a little bit different topic. All right, thanks for watching.